Hi, welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And all of those are going to figure in today with my guest, Jack Lifton. He is the editor-in-chief of InvestorIntel.com and an expert on rare earth elements. Jack, welcome to the Power Hungry Podcast.
Thank you. This is quite interesting to me that this topic is now becoming mainstream. It used to be that no one knew anything about it.
Well, we'll get into that. So, Jack, I warned you I'm going to ask you to. I've given you a brief introduction, but if you don't mind, imagine you've arrived at a dinner party, you don't know anyone there, and you have about 45 seconds to introduce yourself. Please, introduce yourself.
I'd have to do quite a bit of imagining, but let's say that I was in graduate school, and I started working in chemical engineering in 1962. So the very first project I had was what we then called ultra-purification of neodymium, the rare earth element. Believe it or not, this was before the rare earth permanent magnet had been discovered. I was looking at it as an additive in a dopant for electronic devices. And so I couldn't find anybody who knew anything about it. So I had to learn how to handle the rare earth elements, and that became a lifelong interest in this area. So after that, I went to work for a global electronic manufacturer. I did R&D for them, and then I made the switch to management, and I wound up ultimately decades later as the CEO of an engineered materials company servicing the automotive industry. I retired in 1999. And then right after that, someone said, can you please write a column explaining what the rare earths are? I said, okay. And I didn't think about it. And then as soon as it was published, the editor of the journal said to me, what are you going to write about next week? And I've been doing it ever since. Not journals, but popular writing.
Sure.
I've written hundreds and hundreds of articles, given maybe 100 lectures, done workshops, things like that. And things are happening now that never happened before. So the rare earth space is booming right now.
Yeah.
And I find it, excuse me, unfortunate that the U.S. is so far behind. And I want to preface everything today with this. I'm not a kid. My colleagues and associates in this industry who've had hands-on experience, something Washington doesn't understand, it's called getting your hands dirty. They don't do that.
Uh-huh.
People I know do that and also have PhDs and experience, things like that. So
well, let's if we can jump in. So you've been looking at rare earths in one way or another for 60 years, then.
Right.
And writing about it for more than the last 20 or so.
Yeah. The rare earth metal dysprosium was first commercially produced 2 years before I graduated from school.
And so what year was that? 1960?
1960.
Huh. So which was the year I was born. So I guess my life is defined by dysprosium.
This is not copper or iron or things that men have known about for thousands of years. This is something really new. And there aren't a lot of people who know a lot about it.
Sure. Well, so let's jump right in, Jack, because I've one of the things I've been writing about rare earths. In fact, in my fourth book, which I think is the first time we talked in Power Hungry. Now, this came out in 2010. I had a chapter about the idea of the U.S. trading one kind of import dependence for another, right? Trading oil import dependence for rare earth element dependence. And now here, 11 years later, what spurred me to contact you was this piece that was published in the Wall Street Journal earlier this month. And there was also one in the Global Times, which is the state-run media outlet in China, about the fact that the Chinese government is consolidating control over their rare earth elements companies and consolidating assets from 3 different companies into a new state champion called China Rare Earth Group. How important is this?
Well, for us, it's It's very important because it means that, see, the Chinese attitude is that whatever the government does, it has to ensure price stability and social harmony. Those are the two Confucian goals of any Chinese government, imperial, republic, communist. Now, lately, the rare earths have been undergoing price, I don't know what you want to call it, but they're yo-yoing all over the place.
Volatility.
Yes, volatility. So about a year ago, neodymium, for example, was selling for $50 a kilogram. A month ago, it was $150 a kilogram. And yes, speculators, traders, people like that may think, excuse me, I'm going to clear my throat. Okay, no. Speculators and traders may think this is wonderful, and junior miners think, wow, my preliminary economic analysis just went into the black, by huge numbers. This is great, but they're not important. The only important people are industrial end users. And in the automotive industry, for example, they say we can't handle that kind of price increase. So the Chinese are having the exact same problem we are with prices. They're too high. So
was this a creation of the rare earth group then, the China rare earth group? Was it? Are they looking to strangle supply? Are they looking to increase price? What's the end game?
They're looking to maintain the stability of the Chinese rare earth industry.
Uh-huh.
I mean, companies can't handle swings of that size in price and stay in business. And the Chinese are very aware of the details of an articulated supply chain. So they don't want any companies to fail. And originally, when China first condensed its rare earth production into 6 big companies, that wasn't into 6 big companies. That was under the control of 6 big state-owned companies. Each company controlled the rare earth output in its region. So that was because they were concerned about illegal mining and remediation of environmental problems. So many problems with companies that were really too small to be in business without huge, subsidies in the form of loans they never repaid. So they went to their state-owned companies and said, you guys manage this. Everybody's going to have a quota. And if somebody's making 1,000 tons of magnets, but they only have 500 tons of material, you'll have to discuss that with our Justice Department. So it really helped. But the problem is it wasn't enough. Now, China today is importing 40% of its rare earth ore that it processes. It's never before been importing rare earths of any kind, but it's now up to 40%. And the principal source of the important rare earths that China imports is Myanmar. And we know Myanmar has been a political mess for the last year since it had a revolution. And so for a while, Myanmar cut off exports for the reason that most third world countries are now cutting off exports of natural resources. They're saying, we want you to add value in our country. We make more money, our people have high-tech jobs, and we get a lot more taxes. Okay, well, the Chinese have been resisting this, and they certainly, when Myanmar just threw that at them after the generals took over, and they said, we want you to process this stuff here. Well, China's got the largest processing industry in the world.
Right.
And a lot of employees. They don't want to do that. But I believe they're going to compromise. They'll do something, another step, employ some more people in Myanmar. And the trade has resumed. Okay?
So Myanmar is moving ore back to China now.
Yeah.
But let me zoom out, I guess, more particularly at what to me the other news hook on this story to me, Jack, that was key was that just earlier this month, the Biden administration announces major push for electric vehicles. 500,000 public charging stations. They want half of EVs in the U.S. to be electric by half of the cars sold by 2030 to be half of them to be electric. Let me ask the question, because this is what I wrote down here. Is the U.S., by pushing EVs, are we playing into the hand of China on the rare earths issue?
Yes.
We're playing into the hands of the Chinese on this.
China is the dominant player in the global rare earths industry. They produce perhaps 80 to 90% of all the magnets made in the world.
Right.
And of course, they produce a huge percentage of the raw material, and they have 95 to 98% of all the processing, the separation, metal and alloy making in their country.
Well, so let me, if I could interrupt just on the magnet part, because this is the part that, I've done a fair amount of reading on this, but I'm not the expert that you are. But is it true then that, they're sometimes called neomagnets, but these are the magnets, they're permanent magnets inside the electric motors in electric vehicles. Neodymium and dysprosium and terbium are the key elements in those magnets. Is that right?
Almost. It's neodymium, praseodymium. It's easier when you're separating the rare earths to keep those two. They come together naturally in a cut. So in nature, they're usually found in a ratio of 75-25. Neodymium 75, praseodymium 25. Most magnets are made from that alloy because it doesn't pay to separate the praseodymium out. It's more expensive, and it economically doesn't work. So you have neodymium, we call it NdPr. In the industry, it's called, didymium, okay? But in fact, it's neodymium, praseodymium. Then, if you want those magnets to survive high temperature and return to having magnetic strength, in other words, you add dysprosium and terbium. These are heavy rare earths. They're not normally found. They're extremely rare. And up until now, about 100% of them have always been produced in China.
Well, let me ask about that, because I noticed in a piece that you wrote or were interviewed for in 2012 that at that time there was no other country in the world that was producing dysprosium. So nothing's changed in the last decade. China's still 100%. Of the dysprosium in the world is coming from China.
What's changed is that there are 2 or 3 junior mining companies, which are quite advanced, which want to produce which could produce dysprosium if their models work and if they go into business. There are 1 or 2 in Australia, there's 1 in Chile, and there's 1 in Brazil. And there's another source of amounts of dysprosium. It's the rare earth ore called monazite, which typically contains 1% of xenotime, the ore from which the mineral from which we get dysprosium.
So then you said it's 1%. So 100 tons for every 1 ton of viable ore. What is that ratio?
Nothing like that. If I say something has 1% xenotime, it means 100 tons of xenotime has about 8 tons of dysprosium. But 100 tons of xenotime is in 10,000 tons of monazite. Okay, so processing 10,000 tons of monazite, there's only 1 company in the world that's ever done that. And they did not have the facility to extract the dysprosium, terbium, et cetera. So they sold that to the Chinese.
And what company was that? I'm sorry?
Lynas, the Australian company.
The Australian miner, right? Which is one of the, I want to ask about them because I was just looking at their financials, because they seem to be one of the other only companies in the world of any size, and they're publicly traded, that's really active in this marketplace. But let me come back to Lynas, if you don't mind. So I was looking at this White House December 13th press release. They call it an action plan that fast tracks EVs and talks about bolstering domestic production of lithium, bolstering the battery supply chain. Doesn't contain a single mention of rare earths and doesn't mention China. I mean, I just thought that was truly remarkable, given that every new EV, there are a few EVs that don't require rare earths, but every new EV requires, 3, 4, 5 kilos of rare earths?
If an EV is using a rare earth permanent magnet motor for traction, drive motor, right, in the powertrain, it needs 2.5 to 5 kilograms of neodymium iron boron permanent magnet. Now, can you use an AC motor, AC motor rather than DC? Of course. And that's what they always use. But the problem is the rare earth permanent magnet motor is more efficient and lighter. Let's say, I say 5%, but my colleagues in the Society of Automotive Engineers tell me that it's more like almost 10% improvement in efficiency and dramatic reduction in weight. Here's the problem. Weight equals range on a car. You want the powertrain to weigh as little as possible so you don't waste energy dragging the powertrain along.
Right.
Okay. So traditionally in the automotive sector, if you say, I've got a great idea, but it'll add a kilogram to the car, they tell you no interest, none. And then I have been in meetings where grams were talked about. I mean, but it's a new age in the automotive industry right now, and they're looking at even mining sources of rare earths outside of China. And there's no way to predict how this is going to work out, but I will say one thing. The OEM automotive industry in North America knows just as much about the rare earth supply chain as the U.S. federal government does, which is nothing.
It's
okay.
It's pretty brutal,
so
Jack. That's
FBI to raid my home, I suppose.
And you live in Detroit, right? You're
Yeah.
trying to make some friends in your hometown there. That's nice.
No, I'm tired of talking to these automotive guys because they do the same thing over and over again. What they do is they look for the largest company with the biggest market cap and listing on the New York Stock Exchange. That's who they want for a supplier. General Motors did it last week. They decided on a supplier that's never made a magnet, not a milligram of magnet, never made any rare earth metal or alloy, never separated any material. And that's going to be their supplier for the future. So I decided I'm not going to order a General Motors electric car because I'm too old. I can't wait.
Well, you also probably don't want it to catch on fire, I'm guessing. Maybe.
That's another ethic, but
those Chevy Bolts, their sales are really on fire.
Yeah.
But so let me talk about that. You mentioned GM because on December 10th, you published a piece in Investor Intel. And by the way, I'm just returning and reminding you my guest is Jack Lifton. We've been acquainted now for more than a decade. He's the editor-in-chief of InvestorIntel.com. You can find it at InvestorIntel.com. On December 10th on InvestorIntel.com, you wrote a piece talking about, and you wrote this, I'll quote it because it's worth understanding where you're coming from. Projections of near-term EV production proportions for the American and European markets are wildly unrealistic, just based on the necessary critical raw materials and components capacity needed to achieve these goals. The build-out of the non-Chinese EV industry is just beginning in the West, and I think a long, steep, very expensive learning curve is ahead of us. Why?
Yeah. Because we have not been making these items for a very long time. The last time rare earth permanent magnets were made that went into the automotive industry for general use was about a generation ago, about 25 years ago. General Motors at one time had a company called MagnaQuench, and they made the magnets. But not in those days, not for electric cars. It was for the small auxiliary motors on a car, the seat, the window, the power steering. It turned out that they could only be made as miniature motors with rare earth permanent magnets because an iron magnet has to be about 100 times the volume of a rare earth permanent magnet for the same strength. So you couldn't, when people said we got to have power windows and power seats, you may not remember, the first ones were big, thick doors and clunky seats. The motor was so large, they said, this isn't going to work. And the designers were screaming, the car looks bad. Okay. In about 1980, they came up with the samarium cobalt rare earth permanent magnet. And that was used extensively for about a year until it got caught in a samarium cobalt squeeze by a British group. They ran the price up to about 5 times what it had been, and the purchasing department, General Motors, said, "Go back to iron." But Sumitomo at the time said, "Wait a minute. One of our researchers has really done a lot on neodymium iron boron. It looks great." Okay, well, they went into that. Mountain Pass at that time, Molycorp got a new lease on life because they had a demand for this stuff. They never had it before, and the industry was born. Let's say. Now, actually, what's interesting is that at that time, Molycorp's capacity was exceeded. There's a point to this story. And so they went looking for somebody who could do the work cheap. Hey, the Chinese, they'll never figure out how to do it on their own. We could use these guys for coolie labor. Okay, great. So in the early 80s, the company, Molycorp, transferred the technology to China, and the rest is history.
Well, so let's talk about that since you mentioned Mountain Pass, and this is the mine in California. It's the only operating rare earth element mine in the U.S. Is that correct?
U.S., yes.
Right.
Well, technically that's no longer true, but because the Chemours company in Florida is mining heavy mineral sands, and the byproduct of that, they mine it for zircon and ilmenite, the titanium mineral. The residue is monazite. That monazite is now sold to Energy Fuels in Utah, which we say cracks and leaches it and cleans it up, and then makes it into a mixed rare earth carbonate product without uranium or thorium. They recover that and eliminate it, and then they're selling that to the Neo Performance companies, Estonian operations in Europe. So that's actually, they're now ahead of MP. MP sells raw ore.
Okay, so an MP is it's MP Materials, which is the company that's now traded on the New York Exchange that now operates the Molycorp mine. So that the Mountain Pass mine, which has had several different, was Chevron, and then it was Molycorp, and now it's MP Materials.
Well, actually, it was Molycorp, then it was Occidental Petroleum, then Chevron, then Molycorp 2, now MP.
Okay, so Molycorp 2, thank you for that history. So Molycorp 2 was the company that ramped up production at Mountain Pass, and then the prices of the commodities crashed, and they went bust. And now here's another company taking another crack at the same ore body at the same location, hoping that they're going to make a go of it. And this was the firm that you referenced earlier that now has a deal with GM, in theory, to make to supply some of the commodities, but not necessarily the magnets, because it's the manufacturing of the magnet. You don't just need the metal. You have to be able to make the magnet.
You're interpreting something.
Oh, okay.
GM wants to buy the magnets from MP, and MP has announced they're building a rare earth metal and magnet production facility in Fort Worth, Texas.
Okay.
But there's no timetable here, I don't think. At the same time, GM made a deal with a company in Germany called Vakuumschmelze for supplying rare earth permanent magnets. And Vakuumschmelze actually makes about 700 tons of these magnets a year. And here's an interesting statistic. If we assume that an electric car is a 2.5 kilogram magnet motor, right? And we know that VW makes 10 million cars a year, Daimler makes 4 or 5 million cars a year, and let's say GM makes in the US 4 million a year. So that's 20 million cars. So let's see, multiply 20, 2.5. So that's 50 million kilograms. Okay?
Yeah.
And that seems to me it's about 50,000 tons of magnets. Schmelz has made 700 tons of magnets last year. Their big customers are the Germans. And I don't know what it is they're going to provide for GM. They said they're going to build a plant in the United States, but there's no feedstock in the United States. So, and MP, the largest magnet imaginable that's hit a few tons a year would be a gigantic operation for these. These magnets are not cookie cutter made. They're very carefully manufactured, and the customer specifies it. It's not a commodity. You don't just make the magnets, put them in a bag, and sell them. The customer says these are the properties I want, and so
they have to be a certain size, shape, weight, etc.
And magnetic strength. Don't forget that. Okay.
So let me back you up, because if you don't mind, Jack, because we just had a little bit of a latency hit there. So you're saying that if the aim is 20 million EVs of production per year, whichever car makers you take, right? But if we take VW, Daimler, GM, 20 million EVs at 2.5 kilos each. What did you say? That's 50 million kilograms. So then that's 50,000 tons, right? But you're saying that the capacity of the biggest magnet manufacturer in the West is 700?
Yeah, I don't know of any other magnet. Vacuum-Schmelz, as far as I know, are the only magnet manufacturers in the West, and their capacity is currently 700. And as we always say in America, there's no problem that can't be solved with money, right?
Right.
If I take a trainload of money and I run it into the Grand Canyon, I'll be able to fill it with money, right? I mean, that's for sure. But the problem is, if I take that same trainload and spend it with people who don't have any background in what they're doing, I'm unlikely to build an industry that's competitive and large enough for the U.S. President Biden has said he wants 50% of EVs out of the number produced in the year 2030 in the United States. Okay,
right. 50% of all U.S. sales, and sales are about 17 million cars a year.
That's
so let's just say 8 million cars would have to be EVs.
Well, the Chinese will make 30 million cars in that year, and their goal is 40%. So my theory is that Joe took a look and said, I can up that. And he upped the ante to 50%. This was a nonsense prediction. It's not based on any reality, and nobody could meet it, okay? Not in America. China is ready now with the raw materials it needs to make its electric vehicles, its magnets, and all the other devices dependent on rare earth permanent magnets. They're already supplied with enough capacity to meet their 2025 goal of 20% of cars and their 2030 goal of 40% of cars. They believe it. They have enough manufacturing capacity and raw materials. But in order to do that, they've really put a crimp on the rest of the world. And I think the biggest mistake people make is they think, well, the Chinese are getting into the rare earth magnet business. No. The Chinese rare earth permanent magnet business is meant to supply domestically China, the gigantic market, 1.4 billion human beings. And their interest in, they restrict exports. Technology can't be exported. Rare earths can only be exported, as finished goods. And I always tell people that the Chinese are moving towards needing 100% of their output for their domestic consumer market, and the balance will go to the rest of the world.
So China's going to look after China first.
Well, of course. Why is that a mystery to people?
Well, I just thought I'd ask that just directly. This journalism thing, Jack, I can't turn it off. I'm just going to ask that question. So well, let me then ask it again, given what you've just said. So, one, you said Biden's prediction is nonsense, but I asked before, is the U.S. just playing into China's hands when it comes to the whole issue of EVs, because of the supply chain issue is going to be the ultimate constraint on the growth of EVs in the U.S.? Is that a fair statement?
Well, I don't think China was really interested in what the U.S. was doing when it began to do EVs. Now they've seen an opening, and I believe sincerely that China couldn't care less what we do about anything. And so, but once they saw the problem, they moved to solve the problem. Look, they're not going to export anything that they need domestically. They're not going to export anything to us that they think exporting to someone else wouldn't give them a benefit. And this is what our government doesn't take into account. We do not have an industrial policy. China has an industrial policy. When they say they're going to produce 20% EVs in 2025 and 40% in 2030, that's not a suggestion. That's a mandate from people in Beijing to all these companies. And we look at, have you been to China? I've been to China quite a bit.
I've not been at all.
Okay. I've never seen so many Rolls Royces as in Beijing. I mean, they're all over. Okay, fine. So people say, well, these are communists in name only. That's not correct. They are really communists. They're using a plan devised 25 years ago. Let the capitalist system assist us to move socialism forward. That's what they're doing. I was at a conference. I sat next to a Chinese businessman, the guy who makes the Ginzu knives. He did that. And I said, so what is your business model? He said, I do anything the government says is okay. He says, if you do something the government says isn't okay, no more money, and you might wind up in a corrective labor camp. I said, okay. So he said, I got a Rolls Royce. I'm having a wonderful time. I do whatever they tell me to do. That's how the system works there. In America, the President of the United States says, we've got to have electric cars, whatever that is. Yeah, I'm sure he doesn't know. And then he doesn't give orders. Thou shalt mine, refine, fabricate. He just says, we'll let private enterprise do it. That's how it works in America. But the government will interfere enough so it never gets done.
So let me follow up on your point about the industrial planning or industrial policy, because it seems to me that's central to this whole issue. Because in the press release, there's this mention of bolstering the supply chain and working together and la. And similar to what they said on bolstering supply chains on rare earths, but even if the U.S., let's just assume that Biden could say, we want to bolster development of rare earth mining. If we started now, and if we found a big rare earth element deposit in the U.S., again, or Mountain Pass or equal to that, how long would it take to get a new mine up and running and actually producing the kinds of materials needed by EVs? How many years?
Number one, it's mining-friendly jurisdictions. The Fraser Institute in Canada lists 64 mining jurisdictions. They rate them in terms of friendliness. In other words, the speed with which you can get a mining permit. Guess what is the bottom one? Number 64. California. Where's the Mountain Pass mine?
California.
Okay. So, second worst, or maybe first these days, Wisconsin. Things like that. Okay, it doesn't matter because there's iron in Wisconsin, no rare earth. The problem is, if you're in, the deposit is put there by God or nature, whichever you believe in, and then you find it. If you find a monster deposit of rare earths, let's say outside of Los Angeles, it'll just be a curiosity. No one would be dumb enough to try to get permitted to build a new mine in California. Okay, so you have an existing mine. The material it produces is mildly radioactive. And if you go, right now, they're sending that to China. It's not a problem. Okay.
Now we're talking, just to be clear, you're talking about the ore that is produced by MP Materials at Mountain Pass. That ore is mildly radioactive. It's not processed here. It's sent to China.
Right.
Okay.
And if you wanted to process it here, as Molycorp did once, and as Molycorp 2 wanted to do, you build a separation plant, a chemical separation plant, to separate the individual rare earths. These plants use enormous amounts of water, and the waste happens to be salt, NaCl, table salt, and organic liquids. These require separate permitting, to handle these. First, you have to have enough water. And I think they do at Mountain Pass because they use their own groundwater. And they have to dispose of these chemicals. So these are permits that have to be gotten. Then you need air permits. You need a permit. Well, they don't have to dig a mine. The mine is constructed. It's being mined, right?
Yeah.
So
it's a big open cast mine, as you would say, like an old copper, or like a copper mine, or a coal mine. Yeah, it's a very deep pit.
I actually visited there 11 years ago and was given an opportunity to look at all the geology reports. And I think that Mountain Pass is probably the largest deposit of the mineral bastosite in the world. It's the only primary rare earth mine I know of. In other words, a mine that produces one element in overwhelming amounts. That's a primary. I don't know of any others besides Mountain Pass. It's a monster deposit. It could supply us with magnet materials for forever, but we don't have the infrastructure to make magnets. We don't have the separation. We don't have the metal making, the alloy making, and we have
but if we started now, if the federal government could say, Mountain Pass, you're going to be in charge of this. How many years would it take to create that supply chain from the ore to the automobile?
I believe that they're saying they can be producing magnets by the end of 2023. I think they're saying that. Okay. So they're saying 2 years. I'm going to guess from life experience that it's more like 5, 6, 7 years, because the volumes they're looking at have never been produced before.
Outside of China.
Not here.
Yeah. Had never produced outside of China.
Right. So and that's one mine. Now, you can never depend on one supplier in the supply chain. You have to have alternate suppliers.
Sure.
Okay. So we have several ventures moving along in the same direction, like Energy Fuels with its operations in Utah. And then we have a company called USA Rare Earth, which has a deposit in Texas and bought the equipment of the Hitachi magnet venture that was built in North Carolina a few years ago. And that there's one outlier that I think is really got a lot of potential, and that's a company called Rare Element Resources. Its mines are in Wyoming, and the company is now 50 or 51% owned by General Atomics, which just announced that it'll match a government grant of $22 million with its own $22 million to build a separation plant in Wyoming to process ore from the deposit known as Bear Lodge. So,
it's called Rare Earth Element Resources.
Yeah, they are buying into that company, and they've spent a great deal of money, General Atomics, on developing a process to separate the rare earths. So they say they're building the plant, and my guess is because they're General Atomics, a big company, a lot of experience in ultra high tech. My guess is that they will be successful, and in 2 or 3 years they'll have a separation plant there. The company has said nothing about metals or magnets or alloys, but those are the only ones I know of that I think could be brought into production in this decade.
So are any of these investable? Not that I'm looking for stock tips. I looked at Linus
they're all public. Sure.
They're all public. But as Linus, it seems to be far ahead in terms of actual production, but I just glanced at their financials. They don't seem to be making much money.
No, well, Linus is producing quite a bit of material. But Linus separates, they produce light rare earths from a world-class monazite deposit in Australia. And they do the chemical processing in Malaysia. It was originally for economic reasons.
Right.
That is the largest dedicated rare earth separation plant in the world. It's twice as big as anything I ever heard of or saw in China. And it took, here, just a good example as an answer to your question. I surveyed that plant for the Malaysian government in 2012. It was finished, ready to go. The first commercial production out of that plant was 2017. That plant cost 800 million American dollars to construct, but half of that was because they processed the ore. The raw ore was sent from Australia, and they processed the ore in Malaysia. The actual separation part of it was about $400 million. Point is, it took them 5 years to get the kinks out. First of all, the Chinese never build anything that large because they're afraid of if you lose that amount of material in process, that huge amount, it's a lot of money.
Right.
The Chinese typically run 1,500 and 2,500 ton a year separation systems. That they if
And then
something-
they build several of them so that they don't have one.
more than several. They have so much excess capacity. They could, build one of their ghost cities around it. So the problem with Linus is I see it, and here, Jeff, I'll have no friends in Southeast Asia either. I don't think Linus is economically sound. And the only reason Linus is still there is the Japanese government has extended them loans and extended repayment because Linus is today China's only non-Chinese source of rare earths.
So this is what I'm hearing you say when you said that. Just the word that popped in my head is mercantilism. That if there's going to be, okay, well let me put it this way. So if the U.S. is going to have a significant EV market, it is going and therefore needs significant rare earth element inputs and magnets and all the rest of it. It's going to have to be more mercantilist in how it approaches the entire affair. There's just no way that the U.S. is going to be able to meet rare earth element demand unless the U.S. government puts a whole lot of money and political power behind it. Is that a fair assessment?
Yeah. You know what the real problem is? How do you choose where to put the money? We had Selectra, and that's become an icon of a waste. Selectra was a laboratory experiment funded by the taxpayers to the tune of $600 million. It was never really a commercial venture. The problem in Washington, and I've been saying this all my life, bureaucrats talk to each other. When somebody in that room doesn't know anything, they call an academic. Bureaucrats and academics then discuss and they say, here's the ideal solution, okay? And they find out that if they had asked anybody in the industry the same question, he or she would have said, no, you do it that way. But they're not interested because they get university grants, bureaucrats are permanent civil service. They don't have to worry about it. They don't understand what's going on. My own horn, you can cut this part out. I was discussing this in the Department of Defense at a meeting, and they said, what are we supposed to do? I said, I have an idea. What's that? I said, listen to me and let me explain to you what the problems are and how you can solve them. No, we're talking to Professor so-and-so at the Institute. That's great. Okay. Now, I'm not too popular now with these guys.
Say that again, if you don't mind, Jack. We just had a quick latency hit. You said I'll explain it to you, and then they just didn't want to hear the problem.
That's exactly right. I said at the Pentagon, I'll explain this to you. They didn't want to hear.
Well, so then what's the way forward? I mean, you in your piece on December 10th, you just predicted the failure of the EV market, or that simply the prices of the magnets are going to be so high that the EV costs are never going to come down because of the supply chain. Let me put it simply to you. So what's going to happen next then in terms of EV development in the United States, commercialization of EVs?
If our two American companies, General Motors and Ford, were smart, they would go back to Henry Ford, the first playbook. They would buy the mine, buy the companies, and integrate that production into their, until 25 years ago, that's how they worked. They had Ford made steel, glass, General Motors made magnets. Okay, then they had the genius idea of divesting all of this and going back to their core competency, whatever that turned out to be. So
losing money, going bankrupt.
Losing money, correct. Now they really should vertically integrate. Okay, but you can't. It's like you cannot simply say, today I am going to be a magnet maker. Okay, you have to understand what that's going to take, and to do that, you have to talk to a magnet maker or hire a magnet maker, and then. Manufacturing engineering is not the same as laboratory desktops. Okay, every day you read about somebody at university has got a solid state battery. It'll last forever. have infinite power and weighs nothing. Okay, great. But can they make two of them? Well, no, we don't know how.
And can they make them?
And
Can they
how
make them?
about-
Can they make 10 million? Right, which is the
Yeah,
more
10 million,
important
that's
question.
right.
Yeah.
So this is always the problem. Manufacturing engineering doesn't do R&D for you. You show them what you want to make, and they figure out how to make it. And then the Wharton fellows say, wait a minute, we can't afford that, so don't use it. That's how it works. And when the miners and the planners say, well, with neodymium $150 a kilogram, wow, we can afford to mine rare earths in downtown Houston. Great, terrific. Okay, the problem is today's average car in the U.S. costs $42,000. Family of four, prior to the current inflation, was making $64,000 a year. Family of four. How many of those $42,000 cars can they afford, and how often can they replace them?
Right.
In case you didn't hear, the chairman or president of Stellantis, the former Chrysler Fiat, gave a speech last week, which I sent out to all of my colleagues. He said, I wonder if we can afford to build electric vehicles. Maybe they're too expensive.
Well, I didn't see that, but it reminds me of what was the chairman of Audi a few years ago said, what idiot will buy it? He was talking about electric vehicles.
Well, look what Toyota did last week. At the beginning of the week, they were not going to, they were continuing to make internal combustion engine cars forever. By the end of the week, no, we're going electric by 2030. Okay, so who knows? This is common in the automotive industry. If there's a trend, they say, we're going to do it, whatever it is. And keep in mind that all those predictions of 2030 are long after the current top management of the companies retire. So they're going to say whatever they need to say to keep their beautiful bonuses, pensions, etc. That okay. There's no reality.
But what I'm hearing you saying, Jack, to correct me if I'm wrong, is that there's no there that this belief that we're going to switch to EVs. This is the way I thought about it. We're going to trade domestically made gasoline, diesel, and jet fuel for praseodymium, neodymium, and terbium from China. It doesn't seem like a good trade.
No, and the bottom line here is it's even worse because the United States produces a trivial amount of lithium, yet every electric car the size of a Tesla Model 3 needs 8 kilograms of lithium measured as metal. Okay, so 17 million cars times 8, okay, it is 100, let's say 125 million kilograms, right? So that's 125,000 tons of lithium, which is 25% more than the entire world produced last year. How long do you, and let me tell you the absolute most ridiculous thing I hear. 2007, I wrote an article pointing out that lithium that year produced, I think, 16,000 tons worldwide. I call it a rare metal. Anything less than 20,000 tons, I call rare metal. Okay. 16 became 86 in 2020. So multiplied by 5, let's say. Okay. So I read in the Wall Street Journal, New York Times, and Wharton reports that, well, if it multiplied by 5 in 13 years, certainly we can do another multiplication by 5. Do these people, have they had a general education? Do they understand the earth does not grow minerals? That whatever is there is just the scum left over after the formation of the planet? And that human beings are mineral parasites? We eat the minerals and throw them away. We make cars and scrap them. We make radios and televisions, forget radios, and portable computers. And when we're done with them, they go to landfill.
Can I interrupt you because I love this line that humans are mineral parasites? I've never heard that.
We're parasites on the minerals of the natural resources of our planet. We're eating them up without any thought of replacing them. You know what interested me? The first thing I heard in China from 15 years ago, a Chinese engineer said to me, "Why do Americans waste so much precious resources?" And I said, well, because we're pretty stupid and short-sighted. He said, no, we don't believe that. We think the Americans are the smartest in the world. I said, that's our secret. We got you thinking. Okay. But they recycle everything in China. Rare earth magnet companies recycle, mine, anything, any residue is recycled. That's been going on in China forever.
Well, so then what's next, Jack? I mean, you've been looking at this for a long time, and I have to say, what your analysis of the situation is fairly sobering. And I've thought myself, well, how can this even possibly work at the scale of global? So your answer is it can't. That where there's just
of course not.
So then we're all in this mass delusion around this switch to electrify everything.
You're sentencing Africa and India to energy poverty when you do this. When you say you can't use coal and oil and gas, end of the world. Oh, okay. How long do you think the United States and Western Europe can arrogantly just decide how the standard of living in Africa? I mean, I know that. What was he talking about? If we were to garner all these resources to make ourselves electric cars, enough electric cars, we would denude the Western world. And by the way, it's too late. The Chinese have been buying and taking control of these resources overseas from China for 10 years. They've spent hundreds of billions of dollars on mines and fabricating companies. And we can't catch up with them. They have really done a job. They basically own the world lithium market, for example. They make 80% of the batteries used in electric vehicles. They control 60% of the world's lithium. Where are we? This is not, okay, we've got a couple of big lithium companies that are based in the United States, but they don't have deposits in the United States. And you honestly think that, let's say, W.R. Grace, it's not a lithium company, an American chemical company, billion-dollar company, can they compete against China Incorporated, where bank loans repayment is not the issue? For China, security of supply is the issue. Our guys are after profit. If they can't make a profit in the short term, they say, the heck with it. The Chinese say, what will this do to advance our plan? And
if I can interrupt you there 1 second, because what you just said was exactly what I heard. I've only been to Saudi Arabia one time, and I don't think I'm going back. But anyway, when I met with someone with the Ministry of Oil, he was talking about that. He said almost the exact same thing. He said, the Americans come in here and all they want to talk about is price. The Chinese come in, they never talk about price. They just want to talk about security of supply. And I thought it was just remarkable. I hadn't thought of that in a long time until you just said that. But well, so where does this go? I mean, I've asked you that once, Jack, and I'm going to ask it again. So does this mean the internal combustion engine is here to stay? What's going to happen? And are these automakers just destined in a few years to write off tens of billions of dollars of wasted capital trying to go to EVs?
No, they're destined to go bankrupt. Automotive industry is capital intensive, perhaps the most capital intensive industry. You might say semiconductors is more, but semiconductors is small compared to automotive. The world automotive industry is $1 to $2 trillion a year in sales. Mm-hmm. Okay, to design and build a new car from the ground up, maybe $3 billion. To build an assembly plant, $3 to $5 billion in many years. These guys need huge amounts of capital. Okay, so occasionally when they're making money, it's internally financed, but usually it's bank financed or government handouts, right? Okay, now, if a company, I'm not accusing General Motors of that, I'm just making one. General Motors decides we're not going to design any more internal combustion engines, and we're going to limit our ability to manufacture them. We're going to go over to electric motors. Okay, so, but see, BMW is doing the opposite. They're saying we have no plans to discontinue internal combustion engines. So 5 years from now, when you want to buy a sports car with an internal combustion engine, BMW is going to say, gee, we just finished developing this. This is our 2025 Monster V6, blah, blah, blah. And General Motors is going to say, we can give you a 57 Chevy engine, and so
we've got this VA 350 that we've been developing for decades. Would you like that one? Because we get a lot of them.
Okay, and so that's a problem. The other problem is that if, let's say you tool up to make 5 million electric cars, but you only get raw materials to make 1 million. You think that's a profitable operation? See, they're not thinking. General Motors announced they're going to build 4 battery plants. Ford, I think 2 or 3. Other people, etc. When you add up all the capacity of those plants, it's a drop in the bucket. Okay, but the point is, where are they going to get the lithium, the cobalt, the rare earths? Where are they going to get them? They think, as do all American financiers, that if you just raise the price, you'll increase the supply. Okay, well, that isn't true in natural resources.
Because China's looking at it solely from a national, from a national security standpoint.
It isn't true because there is a finite amount of natural resources. China for 10 years has been buying them, control of them. We're new to the game. You know, no American company is building railroads and schools in the Democratic Republic of the Congo. The Chinese are, and they get all the cobalt, okay, and probably the copper. And so we need an industrial plan, policy. We need financing of supply chains. But to do that, we need to understand the supply. What I'm saying to you is that in World War II, Franklin Roosevelt called in the heads of the automotive companies and Henry J. Kaiser. And he said, listen, guys, I need a lot of boats, a lot of tanks, a lot of machine guns and cannons, stuff like that. And they said, when and how much? You know, I don't know what he said, but you know what they said to him? And how do we get paid? And he said, you'll be paid cost and 10%, something like that. Okay. So Henry J. Kaiser went out, and by the end of the war, I think every 3 days he was delivering a Liberty ship. General Motors Ford built more airplanes than Germany did in World War II, in case you don't know it, in Michigan.
Right.
Okay. General Motors, as a boy, I visited a factory where they had on display the drive train of the submarine, which they built in their Saginaw works. Okay, that was not because a bunch of bureaucrats and academics got together. That was because the industrial leaders of this nation got together and they said, we can do this. And how did they do it? The raw materials were directed to them. You couldn't get a tire during the war unless you were building something for the war. Okay.
So well, if I interrupt, so I mean, what I hear you saying is that the only way, I'm paraphrasing what I'm hearing you say, what I think I'm hearing you say, that the only way the U.S. is going to make some significant inroads in terms of EVs, and that is producing them by the millions, is if the U.S. government mandates it and makes it happen, because the individual companies can't. Is that, am I hearing you correctly?
Yes, China mandated it and it happened because they have central control. And what's their control? Their control is obviously the money. When you go to the People's Bank of China to borrow $10 million to build a magnet line, they only ask if you're competent. They're not asking about your ability to repay the loan, or will you be profitable the first day, the first quarter. The question is, can you do it? And then in Beijing, they say, do we need this? And the money flows, okay? And they're, in the Soviet Union, managers who didn't meet their quota were replaced, okay? So in the Soviet Union, they made as many tractors as possible, even though there was no market. That was their failure. The Chinese noticed this, and they're not doing that. They make things for which there is a demand, and in fact, they create the demand. For example, when they say you will make 20% EVs in 2025, it's not a suggestion.
And part of that is their own national security, by as I've understood it, to reduce their need of the amount of oil that they need by putting more, because they can fuel the EVs with coal or with electricity that they can generate from coal. They don't have, which they have domestically. They don't have to import the oil. So their security, is it true that their security view on this is more nuanced than a lot of people understand? Is that fair?
Well, I really think that, considering how polluted Chinese large cities are, or were, that they immediately realized that cars were really contributing to pollution in the cities. Now, they moved steel mills away from the cities. They moved other industries that create a lot of particulate. And I think they decided, if we go electric, we eliminate one big cause of air pollution.
I see.
And so that's for social harmony. See, and then people tell me, no, they're trying to save the earth, global this and that, cooling, warming. I can't keep track of this crap. But what they're doing is trying to clean up their cities. I mean, Chongqing, China has more people than California. Okay, it's a city. So
Right.
it's really polluted when you have a million ICEs running around, and people tend to not keep them exactly in tune, so
Sure.
they blow
Yeah.
out carbon, and they steal the catalytic converter. All that stuff is going on. So they said, the solution to the problem is not to educate people, but to replace that industry, and they're doing it. But they're the only country in the world that can do it. They have the autocratic kind of government. They have now got the raw materials. They've got a gigantic car industry, much bigger than the American, okay? And they're the world's biggest maker of the batteries and of the components of the battery and of the rare earths for the drivetrains. And this wasn't in America, it's accidental this all happened. In China, it was a plan, and the plan worked.
Well, so then what's next, Jack? We've been talking for more than an hour now, about an hour. What's next? How does this unfold? Is this the automotive sector that we have now, the auto sector we're going to have for decades to come? What's going to happen next?
You're always, listen, I'll tell you what, I'll promise you, if you buy an electric car and there's a power shortage, I'll only send an electric ambulance for you. So if it doesn't make it, I'm sorry.
I'm not planning to buy an electric vehicle. For the record, I'm not. I've had the vehicles that I have are the ones that I'm going to have.
How about this one? The accessory on a main battle tank will be a 5,000 miles extension cord.
Okay. Now you're pulling my leg, Jack. What's going to happen? Give me the straight poop. What is going to happen?
As Humphrey Bogart might have said, we'll always have internal combustion engines in cars. Okay. Now, if the people in Washington are foolish enough to make the price of gasoline sky high, we'll simply go into a sharp recession over that. Because America moves on 300 million ICE vehicles, okay? And they're actually doing that, in my opinion. They're making the price of gasoline too high. So the end result will be that Americans drive either internal combustion engine cars or Chinese-made EVs. Now, sooner or later, the capacity of Chinese production will exceed the market. And they will then be able to export. But they'll export cars that have Chinese lithium, Chinese cobalt, Chinese rare earths. We will do nothing to that, except the dealerships.
All right. Well, so so you're saying that eventually then, because we won't be able to produce EVs profitably, the U.S. automakers won't be able to produce EVs profitably here, we'll eventually be importing Chinese electric vehicles.
I have to say that I never was a fan of Elon Musk because as a native Detroiter, of course, he was against the grain. But you know what? He's turning out to be right. And my guess is that
how is he turning out to be right? I'm sorry?
He created a market. The battery-powered electric vehicle back in 2005, and it looked ridiculous at that point. Okay, it was a game. And now I think he may have created an industry, but it's a limited industry. It's going to be limited in this part of the world to luxury vehicles. They're expensive, and like my brother's electrical contractor, he said, it's only going to be $5,000 to put the charging station in your garage. I said, that's great. So if I don't buy the car, I just save $5,000 more. Okay. And we have power outages. We don't know if we have enough power. And I have to tell you that I do know a retired vice chairman of General Motors who only 3 years ago said to me, it ain't never going to happen until we have hundreds of thousands of charging stations and the grid to support it. I don't see anything happening there. This idea, the Canute approach to government, thou shalt build 500,000 charging stations. And how are they going to do that? I mean,
it's going to be crazy.
Don't they have to wire them up?
Yes. So, it's going to be crazy expensive. So, Jack, just two more questions then. These are questions that I ask of pretty much everybody that's on the podcast. So what are you reading these days? You have books on your bookshelf? Are you a reader? What do you like to read?
to be honest with you, I read economic analysis, especially historical analysis. And I read all the national newspapers of the United States and Great Britain every morning. And I subscribe to the China Daily and things like that. I really read voraciously because there's so little actual journalism in the United States. If I didn't read the British papers and the Chinese and Japanese, I wouldn't know anything that's going on in the world, because their point of view overseas is quite different than ours. I'm not saying that they're not, their governments are wonderful, their prime ministers aren't Looney Tunes. I'm not saying that at all. But you have to really get information, as much information as possible, to get any information, because there's so much bull out there. Wow. And when I see things like we were talking about today, we're going to build 50% EVs by the year 2030. And this is repeated by institutional finance, banks, universities, politicians. And I think, how can these people be so uninformed? I really don't know. But when you don't teach history for the kids today, begins the day they were born. And I always tell people, I've lived a long life. I've done everything wrong possibly you could do wrong. But that's why I'm good at giving advice, because I know what you're doing isn't going to work, and I'll tell you why. But I found out they don't want to hear it.
Well, that's rather sobering. Last question then, Jack, and my guest is Jack Lifton. He's the editor-in-chief of InvestorIntel.com. What gives you hope?
I don't think there's going to be any devastating war. And I think that the United States is going to slide into a genteel second place in the world economically. And that if you've got any money, you're okay. If you know how to make money, you're okay. But I don't see a good future for people who have not got any saleable skills. I think the United States, after World War II, 1947, was the strongest nation in history, the richest nation in history, etc. That was the peak of the United States, in my opinion. And we've lived through the rest of it, the decline. It's been very slow, but if we don't adopt things like industrial policy and America first, I'm not talking about Donald Trump, I'm talking about common sense. If we don't adopt what we do for ourselves first, like the Chinese, the British, the French, everybody else on earth, then we're just going to slowly decline. Now, like, we have a lot of nuclear weapons, a lot of ships, missiles, aircraft and men. Okay, so nobody's going to attack or take us over. But what happens if nobody's listening to us? And I think what I'm seeing in the world in my lifetime is America's respect. The respect for Americans by foreigners is gone. The Chinese are beginning to hold us in contempt. And that's a bad sign.
Well, I'm not sure that's what gives, the question was what gives you hope. I'm not sure you answered it that way, but that's okay. We'll end it right there. Jack, it's been great. It's been great to catch up with you again. Your analysis is sobering, but very well informed, it seems. So thanks again for being on the Power Hungry podcast.
Okay, no problem. If you want to be depressed, call me.
So to all you out there, this again has been an interview with Jack Lifton. He's the editor-in-chief at InvestorIntel.com. You can find him right there, InvestorIntel.com. Thanks for tuning into this episode of the Power Hungry podcast. Until next time, see ya.
Thanks very much.